Hello. In this video, we're going to be learning about how to read and interpret an F distribution. First, we need to know what F actually is. It's a test statistic that we use to determine any statistically significant differences among group means. This is very similar to the T statistic that we use with T-tests. However, T-tests look at single variable differences, whereas F-tests look at group variable differences. We're going to use these a lot in our ANOVA family of tests, as well as regression analyses. And every F statistic has an appropriate F distribution. We also have an F value or an F ratio, which is going to be the between groups differences over the within groups differences. And there's also two other calculations to get that same value. Here are two ways we can compute an F statistic from known data. This is going to be known as our F value. We can use sample standard deviations as well as population standard deviations from two different groups, or we can use sample chi-squares and degrees of freedom from two groups as well. These are both going to get us the same F value. In order to apply this F statistic, we need to compare the F value that we calculate from the data we have to the F statistic or critical value, also known as F crit. This is going to be a fixed value, which we'll find out how to find later. If our calculated F value is greater than F crit, we reject the null hypothesis. For our ANOVA test, this begs the question of, is the variance between the two means significantly different? If we reject the null, obviously we say that yes, they are significantly different. However, we still need to interpret and apply the p-value. That's because the F value does not assure that all of the variables are significantly different. It could just be one of the few variables that we're looking at. The p-value will tell us if there's significantly different values between all of the variables. This is also very important for regression tests. We need to look at the p-value first, then the F statistic. If the p-value isn't even significant, we don't even need to look at the F value at all, because we assume then that our added coefficients have not improved upon the existing regression model. There's no significant differences. So what is this F distribution then? It's a distribution of all the possible values of an F statistic. It's an asymmetric graph. We see it peaks just to the right of 0, and the higher the F point is, the lower the curve becomes. It's actually a collection of individual distribution curves, with each curve depending on its own degrees of freedom. As we see in the graph in the bottom right here, different degrees of freedom will lead to different curve shapes. So we need to know the degrees of freedom of the numerator as well as the denominator. dfn is going to be the number of groups minus 1. This is also seen as v1 or df1. We might see the number of groups as k. df denominator is the number of subjects minus 1. We might see this as v2 or df2, and of course, number of subjects is going to be n. If we saw an F with degrees of freedom of 5 and 9, this would be an F distribution with df numerator 5 and df denominator 9. The order is very important. If it was df n was 9, df d was 5, it'd be a very different looking curve. So we use these degrees of freedom value with our F table. This gives us a probability for a certain alpha level. We read across the top to the right for degrees of freedom n. We read down the left on the side for degrees of freedom d. Gives us the area in the right tail. The area under the curve to the right of F crit is going to be that alpha level, as we see shaded in the graph on the top right. The rest of the area under the curve, of course, is equal to 1 minus alpha. We find our F value. We compare it to the F critical value that we find in the table by cross-referencing the degrees of freedom. And if our value is greater than F crit, we reject the null. Here's an example from the realm of exercise physiology. This was actually an abstract that Dr. Mullen and I submitted late last year. We compared the effects of anabolic androgenic dose size and duration on men's sexual health via questionnaire. It was a 2x2 between groups factorial ANOVA design with an F distribution of 1 and 45. Our F value was 0.087, which was much less than the F crit of 4.06, as we see on the table snippet on the right. And thus we concluded that there were no statistically significant differences between the groups. Thank you very much for watching.